Hey everyone, it is January 1st, 2025, and I'm going to be doing a oxalic acid vapor treatment here on my bees. And one thing I've been up against is, well, I'll just show you. So many of you probably use this wand here, which you hook up to a car battery or a 12-volt battery source, and you got to get it to a certain temperature before the acid will vaporize. And then you take a spoonful of this stuff here, put it in there, it vaporizes inside. So one thing that I'm always dealing with is either lugging this big battery around, or every time I want to do a treatment, this battery is not charged enough. So I'm constantly trying to keep it charged. And it's just a bit of a pain in the butt lugging it around and getting it to temperature and stuff like that. So I am about to attempt to create my own setup here with some electronic devices. Try to build basically a vaporizer that will be easy to carry around, be ready to go whenever I need it to, and make sure we get to the right temperature for vaporizing. So in the past, I've used like a laser and tried to guess what the temperature is, but I thought it would be better to create something. With my electrical background, I figured I could probably piece something together. So I've come up with an idea, and I'm going to start putting it together and giving it a try. And I will update this video in a little bit with the update. So the goal is to build basically an InstantVap, but not for $700, but essentially to get the same product by using some homemade kind of online components and being creative. I was thinking about what could be a good power supply that is super handy, easy, lightweight, and most people have it. So what I came up with was Milwaukee battery. It's 18 volts, not 12, so we got to deal with that. But if I can convert power from here, if I have enough amps to power the this bad boy, the wand, then I should be good to go. I don't know how long it'll last per colony to do a treatment, but if you can fly through the bee yard pretty quickly, you might be able to get quite a bit done before the battery dies. So what I did was I picked up this bad boy from Amazon, which is basically an adapter here that takes the battery, and depending on what power output you want, you can buy a transformer like this. This was an all-in-one set for I think 25 bucks or something Canadian. This is a DC to DC, which is what we want. Output 17 to 55 volts. Oh, sorry, input 17 to 55. We're putting 18 in. All right, putting 18 in there, and we want 12 out. And this is an output of 12 with 20 amps. There's plenty of juice. So yeah, so we're gonna have to connect the battery to here. We're gonna have to find a way to connect this to the wand. And then the next thing we need to talk about is the temperature. So we need to know a temperature. We want to have a proper temperature for the vaporization of the powder itself. If it's not hot enough, it will just smoke, but it won't vaporize the same way, and you just won't get the same effect. So this particular digital one, this can take a high rating. I think this goes up to like 400 Celsius or something like that. So 200 Celsius, not a big deal. You can get these also on Amazon, about $25, and they come with their own temperature probe. And yeah, we're just gonna screw that into the block. Okay, so the first thing I'm going to do is I'm going to attach the temperature, like the thermometer part of the temperature sensor. So I'm just going to drill a hole, and I'm not going to bother tapping it. I'm going to drill the hole a little bit small, and I'm just going to thread this in. As long as there's contact, I'm going to get the temperature reading that's good enough for me. So not looking for a professional setup here. If I had a tap and die set, I'd put threads in there, but I don't. So I'm just going to make sure it gets in there and makes good contact with that block there. And that will be kind of step one of building this thing out here. I've tapped that into the block there. It's not loose, it's nice and light. It's steel going into aluminum block, so it bites pretty good there. And We no longer need the alligator clips because we're not going onto a big car battery. So now we just need to wire up the rest of this thermometer here. We're going to wire it in. We're going to get the power supply all set up. I'll put it all together, wire it up, and go from there. So yeah, first thing we do, chop off these things. You don't need them. You can save them for another project, but cut those off. Those are gone now. And now we just have the wiring coming off the unit here. We've got the wiring coming off of here. We're going to take our Milwaukee setup situation here. So obviously the battery clips onto here. We've got the 10 amp fuse. I think it's a 10. Might be a 30. It's a 30. I'm going to put a smaller fuse in there. We don't need that much juice. And then we have the positive coming off here and the negative coming off here. So we're going to go positive, negative, connect it all together. I put a little piece of red insulation on here just to identify which one was my positive before I cut those alligator clips off, because it just has two black wires. So the positive wire will run down and go onto the heating probe here, and then the ground wire, it runs down under the handle here and goes into the block and grounds it out inside there like that. So I do also have some additional heaters I picked up online to give you an idea of how this works. So this goes inside here. This is the heating element. The positive goes onto there. The negative, this is grounded. So yeah, so that's how we're gonna set this all up. And of course the thermostat here has a wire that goes up and is connected onto the thermometer there. So we're gonna hook it all up and see what happens. We're gonna just see if it turns on and do a bench test. But the next thing I'm gonna wanna incorporate into this is a switch, because right now the only way to turn this on and off is to slide the battery on and off, and that's super annoying. So we're gonna wanna have protection on the power and we're gonna wanna cut the power. We can either cut the power here, going to the transformer, or we can cut it coming out of the transformer on the hot wire. So I'm probably going to put it along here anyways. So yeah, let's connect it all up and see what happens. Okay, it's time for the moment of truth. Now this is just a bench test, connecting everything together to see if it'll electrically work. The next thing is to make it pretty and compact and, you know, a nice little tidy unit. So we've got our power, got our 18-volt battery into our adapter here, going through our fuse. This is currently a big fuse. I'm going to put a small fuse in there. I'm going to measure the amperage and see what this actually draws, and then I'll fuse it appropriately. Got the transformer, brings us down from 18 to 12. And then we have all of our connections in parallel, so everything gets 12 volts, connecting up our thermometer, which has its own temperature probe. And then we I put an inline switch just because there's no way to turn this on and off without removing the battery. And then I put a little LED light in just so I can actually see when the thing gets turned on with a red light there, so I know when it's on, because this could probably burn something down. So another thing I want to do is measure the amperage on here. I want to know what kind of current is being drawn through this setup, and that will change as the heater heats up. The resistance will go down as the resistance will change as the temperature changes as this heats up. So let's get this over here onto amps, clamped onto around the positive there, and let's just take a look here. Let's get that to go down to 0, and then we're going to flick the switch on, and we are going to see if 3 things happen. 1, the light comes on. 2, this thermostat tells us what the temperature at this point is. And then the third thing we want to do is see this heat up. The goal is to get this super hot. So we're going to come back and do some extra measurements, but let's flick this on and see if we even have a working prototype here. Okay, light is on. Let's see if amperage increases or decreases. See what it does. Our thermometer has come on at 21 degrees. Just give this a touch with my fingers to see if we're feeling it warming up, and we are. It's getting warm. Temperature going up. 21.8, 22. Current is super low. So I mean, I'm going to throw a 5 amp fuse on here, or a 2 amp fuse, or the smallest one I can actually find. So Oh, this is AC amps. I have it on AC amps. Never mind. I'm gonna have to solve that another time with the amperage. But for now, let's just check out the unit. We're up to 30 degrees, and it's gonna start smoking here. And we're gonna see how long the battery lasts. We also started this with a fully charged battery, and after playing around with it for the last hour, I'm already down to 2 bars. So this will shut off by itself, I believe, when the battery gets to a certain level. So let's see how high. I want to see how high we can get this temperature to go before it dies. But I'm not going to record that whole thing because that would be boring. So I'm going to stop here and come back shortly. Okay, we are getting up to 197, 198 degrees Celsius. It's 230 is a really good number. If we can get to that before the battery dies here. The cool thing is if you were using this and you had a couple batteries on the go, you could swap out a battery before it cools down. So you're not going to have to keep heating it from cold every single time. I mean, it's like, you know, snowing out. So it's like -3 out here right now. So yeah, let's keep watching this. 207. We'll keep her going, and then I'm going to try some acid in here, see what happens. All right, we are up to 222 on there, and I'm just going to check kind of how accurate I think it could be. I think that the probe is probably more accurate than the laser, but I mean, we're getting 205 degrees Celsius here, so we're not too far off, but we are 8 degrees away from being at our ideal temperature here, and I think that's good enough to try out some vapor. So let's get some get a mask on here, and I will put a little scoop on there, and let's watch and see what happens. Here we go. We are 229 degrees, almost 230, which is ideal. There we go. We've hit 230 on one battery. That wasn't even a full battery. I'm going to put a little bit of vapor on here using the oxalic acid here, and I'm going to put on my mask here and dump it on. All right, we have successful vaporization. Circuits held together. We're hanging out around 231 degrees, 232. So that's kind of where we want to be. So that's great. Our light's still on. Everything's working. We still have some battery there. So I'd say this is successful, except for, of course, I'm melting the thing right into the plastic lid there. But that's okay. Let's turn this off, and I think we're successful so far. Now we just need to make it pretty. So you can build this yourself pretty easy. Just go online and find yourself a vaporizer and the power adapter and the thermostat, and put it all together and enjoy. Happy beekeeping.